We're now going to talk about the scope of a variable, a very important matter, especially because it will help you avoid specific types of compile time errors. What do we mean by scope? The question that we try to answer is where in our code can we use a particular variable? So we declare a variable at a particular line, where in the code can we use it? Also, is it possible to give the same name to another variable at a different point in the code? These are the kind of questions that we try to answer. And here is the basic rule that we need to follow. We can use a specific variable from the point of declaration until the end of the enclosing block. What do we mean enclosing block? You need to be thinking about the curly braces. For example, we are writing a method, and inside the method body we are declaring a variable. Where can we use that variable? We can use it from the line that we declared it until the end of the method. We will see specific examples in a little bit. Special cases that may be more puzzling to figure out the scope. Parameters of methods. The parameters are accessible within the method body. It is as if we were declaring the parameters at the very first line of the method body. So we can use them anywhere we like inside the method, and inside the method only. Also, loop variables. Bring in mind a for loop. Think of saying, for example, for int I becomes equal to 0 and then anything else. Where can we use that I variable that we just declared inside the for loop? We can use it within the heading and within the loop body. After the loop is over, the code of the loop is over, that variable is no longer accessible. In addition to the basic rule that we mentioned about the scope of variable, we need to also keep in mind some limitations. And what are those? We cannot have two variables with the same name active in the same scope. That will be a compile time error, as we have already mentioned. So if I declare string y within the same enclosing block, I cannot go a few lines later and I declare again another string y, even if it is for a smaller scope, for fewer lines of code. For example, within another enclosing block. We will see examples about that. Some special cases to keep in mind. We can have parameters and local variables named the same as a field in the class. We say that the field will then be hidden, the parameter or the local variable will be hiding the other variable with the same name. How can we access the hidden variable, the field? By saying this dot field. How do we access the parameter or the local variable? By just using the name. This should not be something surprising. You have already used this in many constructors so far. A notion similar to the meaning of scope is extend. They are different, however, and we need to make sure we understand the difference. When we're talking about scope, we are looking at where the variable in the code is visible. When we're talking about extend, we're trying to find out how long the value of that variable is kept in the system. For variables, the lifetime, the extent, is pretty much the same as the scope. As soon as we leave the block of code where the variable was declared, then the value of the variable is also lost. So if I declare, for example, inside the method body a variable called z, as soon as the method completes its job and finishes, then the value of that variable, the local variable inside the method, is also lost. Similarly thinking, applying the same logic, when we have a block of code that is a loop, then the initializers are redone on the block entry. This is what happens with variables. If we look at objects, the lifetime of an object lasts until there is no reference variable on it. What do we mean by that? Think of the example, for instance, customer C becomes equal to new customer. When we're saying new customer, this is where we create the object, and then we put the variable C referencing that object. If on the next line C references a different customer object, and there is no other customer variable referencing the first customer object, then that first customer object is no longer alive. Its lifetime has ended. In Java, we don't have to collect such dead objects, objects that no longer have references on them. We, the programmers, don't need to do anything about them. The garbage collection, the Java garbage collection, will take care of freeing the memory that was allocated to these objects. In different languages, the programmer is responsible for explicitly freeing that memory.